This is a story about love, betrayal, and chemical chaos. One day in the deep blue sea, Calcium was waiting for their friend Carbonate. They were planning on heading over to the coral reef and help some friends with their calcification. Calcium and Carbonate were a great team, and together they played a very important role in ocean chemistry. Carbonate was also looking forward to this excursion, but on the way they noticed something quite odd. Floating down from the surface were carbon dioxide molecules. Now, this wasn't too unusual. Carbon dioxide frequently dissolved into the ocean from the surface, but lately there had been a lot more than Carbonate had ever seen. Carbonate saw many of them chatting up some water molecules, and they really seemed to hit it off. After a few moments of excited conversation, Carbonate noticed that they reacted and became carbonic acid. Calcium was getting worried. Where was Carbonate? It's not like them to be late. Carbonate continued to watch carbonic acid. Just as quickly as it had formed, the molecule dissociated into two completely different ions, hydrogen and bicarbonate. They both seemed upset over the breakup. "I can't believe I let the relationship change me," said bicarbonate as they wandered off into the abyss. Carbonate decided to go comfort hydrogen. They started having a really nice conversation. Like really nice. They were really hitting it off. "What's taking so long?" said Crassy the oyster. "I can't secrete new shell on my own, you know." "I know," said Calcium. "I'm sure Carbonate won't be too long." Meanwhile, Carbonate was having the time of their life. Hydrogen was so charming, and Calcium had completely slipped from Carbonate's mind. They decided to join together and become bicarbonate. Calcium looked up at the surface and noticed the influx of carbon dioxide molecules floating down, just as Carbonate had earlier. Calcium wondered, "I feel like there have been a lot more hydrogen ions around since the carbon dioxide started coming in. What's going on?" Calcium felt uneasy. They recalled another calcium ion telling them about their missing carbonate mate too, and how difficult it seemed to find new ones these days. "Come to think of it," thought Calcium, "there have been some strange things going on lately." Calcium noticed the coral reefs and the shellfish struggling to grow larger. The clownfish seemed oddly aggressive. "Hey, you want to fight?" said the clownfish. And the rockfish seemed more timid than usual. "Are you going to hurt me?" said the rockfish. Now what in the sea is going on? Well, we actually have a name for what's going on, and it's called ocean acidification. Humans have been expelling an incredibly large amount of carbon dioxide into the atmosphere. Almost half of this carbon dioxide is absorbed by the world's oceans, where it dissolves and chemically reacts with other molecules. Carbon dioxide and water react to form carbonic acid, which breaks into hydrogen and bicarbonate. The hydrogen ions become plentiful and bond with carbonate ions to create more bicarbonate. Repeat this process a few times and we've got a shortage of carbonate. The problem is that calcifying organisms like corals, bivalves, and gastropods need to take in the carbonate ions to secrete their calcium carbonate structures. Research is showing species with stunted growth and deformed shells, even as larvae. This affects those species, yes, but also all of its predators. The pH scale goes from 0 to 14, with 0 being most acidic, 14 being most basic or alkaline, and 7 being neutral, like pure fresh water. Now remember all those hydrogen ions from the story? They make the pH of the water become more acidic. In 1751, when humans began to grow their industries, the ocean's pH was at about 8.25. From then until the 1990s, it dropped to 8.14. This may not seem like much, but pH is on a logarithmic scale. That means that the pH actually dropped by about 30% in that time. And that's a really big deal. Imagine all those marine organisms who aren't adapted to living at that level of acidity. And it's going to continue to drop as our CO2 levels increase. Note that the ocean isn't actually acidic because it is above 7. But what we have to consider is that the organisms aren't adapted to living at those levels, which is why it's important for us and for them. There is still a lot more to learn about how this is going to influence our oceans and even us on land. I really encourage you to educate yourself and learn more about ocean acidification, what we can do to help, and how our impacts have affected others. And now, a fun fact! This is Glenn, the coccolithophore. Coccolithophores are teeny tiny calcifying phytoplankton that are threatened by ocean acidification. They are at the base of the marine food web, so they are very important. They release a molecule called dimethyl sulfide. This molecule goes up into the atmosphere, and as it so happens, their nuclei cause water vapor in the sky to condense. In other words, they make clouds. Clouds have a high albedo, which means that they reflect sunlight and radiation, which, in turn, helps to keep the Earth cool. Now take that, global warming! Gogolithophores are just another organism that are essential to Earth's processes, but are also threatened by the dropping pH of the oceans. Until their demise, they will continue to serve their crucial role. Thanks, Glenn. You go, Glen Coco.